So this is 7.3a in matrix operations, still studying chapter 7, systems of equations and matrices. And this section here, there's going to be some easy stuff and there's going to be some stuff that's a little more challenging. I think it's only challenging because it's new stuff. It isn't really hard to do if you kind of follow the concepts. And after teaching this over the years, I've come up with some ways that do make doing this a little bit easier, so hopefully it will make it nicer for you. We'll see what I can do here. So the first thing we're going to do is we're going to do addition and subtraction of matrices. Pretty straightforward, pretty simple. In fact, I'm going to start with example 1, B as in boy. I'm going to skip A. I think A just kind of makes things a little more confusing. So let me get a picture of that on the screen. So before we get started in adding these two matrices, let me first bring up the fact that in order to add and subtract, you have to have the same number of rows, so 3 here, and the same number of columns, 4 columns, 4 columns. Okay, so because that's true, we can do this. If it is not true, then we say that it's not defined, and I don't think they'll give you anything like that. So really all we're going to do is make a matrix, and it's going to end up, see, this one's a 3 by 4 and this is a 3 by 4, and any addition and subtraction you're going to end up with the same dimensions. So we're going to take that and that, and we're going to add those together and put them here. We're going to take 3 and 4, negative 8 and 2, 0 and 4, and that's pretty much all there is to it. And then we get, okay, not really too hard. When we do subtraction, it's the exact same thing, but instead of adding the two, like the 1 and the negative 1, we subtract 1 minus negative 1, which would be 1 plus 1, which would be 2. Okay? So, minus is the exact same way. The idea has to be the same. They have to be the same dimension, and they have to be subtracted, and you just replace the new answer with whatever the difference is. Okay, one of the key things, and let me erase all this stuff up here. One of the key things that you're going to have to work on with me and understand with me, which is real simple, I'm just kind of mumbling until I get this erased, is understanding the place of each of these, they're called elements, each of the elements in the matrix. Okay, if you do see it later on, and I don't know if they'll bring up or not, they give you an I and a J. Okay, I is the row, J is the column. So anyway, if that's mentioned later and I forget to bring it up, there it is. So anyway, let's keep going here. And I'm going to skip example 2 because that's just a subtraction. You know, you've got 2 minus 1 is 1. And what I would suggest doing is using your graphing calculator and trying the ones for example 2, you know, subtracting matrices on your graphing calculator, just so you're kind of familiar with what's going on there. Okay, example number 3. Let me get a picture here on the screen. Okay, so there's the example, and they give us life expectancy for white males at different years. Wow, 54.4 in 1920. I'd be dead. Okay, females, black males, and black females. So notice that the life expectancy is kind of different. I mean, gosh, it was 55 in 1920 and down to 45 in 1940 when everybody else seemed to be going up. Anyway, so there's our table. And so part A says make a matrix W. There it is, W equals. Make a matrix. containing the life expectancy for whites. So there's our life expectancy for whites, males, females, and a matrix B for blacks, black males, black females. Okay? Use these matrices to find the matrix D, which equals W minus B. So this matrix minus this one. So we took this, minus this, and got that. This, minus this, and got that. One of the things that you need to remember is you're very, very concerned in adding and subtracting that you are adding and subtracting the right row and the right column. So if I'm in the 1, 2, 3, 4th row, first column, 1, 2, 3, 4th row, first column here. So 70.7 minus 63.8 gives me 1, 2, 3, 4, 4th row, first column. Okay? And pretty much C says, what does that tell you about race and life expectancy? Well, we conclude that for this one, the age of death is higher. The life expectancy is higher for whites than that for blacks, for all birth years and for all sexes. All sexes, both sexes. Okay, so you can also do that on your on Excel or on your graphing calculator. Okay, so let's do some multiplication, which is the next section there. And multiplication is basically a little bit easier than adding or subtracting, just because multiplication is easier. Okay, so multiplication is written this way. 2a, that's if you're going to multiply this entire matrix, which is called A. If we're going to multiply it by 2, we just say, what is 2a? That means you're going to multiply 2 times the matrix A. Now, you can do it in two ways, just like you can multiply in two ways. I mean, if we've got 2 times 4, that either means 2 times 4 is 8, or 2 4s added together, which also give you 8. This, you're not going to use that. I don't know why they even told you that that's an option, because you're going to multiply just because it's easier. Okay, so the way you multiply is you take basically matrix A and multiply each element in A by 2. Okay, so we're going to multiply 2 times 1, 2 times 6, negative 2, 3, 4, negative 3, and we're going to get this right here. So like for example, this 8 came from multiplying 2 times this 4 right here. And that's all there is to multiplying by a number. All right, we're going to later on be multiplying matrices by matrices, and that is a little bit, it's not really hard. It just can be confusing if you don't keep things straight. And since I'm very OCD, I try to keep things straight, so hopefully that'll make life better for you. All right, so let's see if there's anything I missed here. I don't think so. All right, so example 4, they're talking about price increases, and they pretty much give you the matrix of the table 7.7 as being 32, 23, 2.6, 3, 1, and 0.60. Okay. Notice there's no augment there. There's no line, meaning equal or anything. It's just the matrix. All right, so that's our matrix of the purchase price of plywood, siding, and 2x4s, and the delivery cost of plywood, siding, and 2x4s. And what happened is there's a 5% increase. So we are increasing the price of each one of these things by 5%. Okay, so what are we going to multiply each one of these by? Well, you would think 5%, but no, we're going to multiply it by 1.5, or I'm sorry, 1.05, because that represents, the 1 represents our original cost, the 0.05 is 5% in addition to our regular cost. If I multiplied this by just 0.055%, I would get these little tiny numbers, which works if I were to multiply, let me get a calculator real quick. If I were to multiply 0.05 times 32, I get, let me do this in blue here, I get 1.6. Well, that isn't an increase. We went from $32 to $1.60. But what that 1.6 is how much the price went up. So now the price went up $1.60, which means it costs $33.60. But if I multiplied that 32 times 1.05, that gives me $33.60 without having to raise add 32 to that. I don't have to add these two. So if I put a 1 in front of here, and that's true with any increase in price, if I just take my percent increase and put a 1 to the left of the decimal, then I don't have to add this and this to get my 33.60. I just take 1.05, multiply it by that, and I get my 33.60. Okay, so it's just a real simple way of not having to add the two prices to get the increase. All right, so anyway, that's example 4. So let's jump to matrix multiplication, and we'll do that in the next video because that's going to take a little bit more than 5 minutes here.